Hello my dear students, today we are going to discuss another chemistry lesson in Guru Gedara science program, and we are going to discuss grade 13 chemistry lesson. So, we are at the end of unit 11 chemical kinetics. There are several competencies already we have discussed. Let us see what are the competencies that we are going to discuss today. So, we are going to discuss the first one, methods to determine order of a reaction. So, that only we are going to discuss today. Now, in a previous lesson we discussed what is this order. If you can remember the rate law, it gives the exact relationship between concentration and the reaction concentration of the reactant. So, order is a something which gives this exact relation. So, let us see how to we determine this order with respect to a certain reactant, and there are two methods. What are the two methods that we can use to determine order of the reaction? The first method is, actually these both methods are applicable when you have more than one reactant. So, the first method is we keep all the concentration of all the reactant at a constant value except one. We keep concentration of all the reactant at a constant value except one reactant. So, then order with respect to that reactant can be calculated, that means the one which is variable. The second method is, in that one we keep one reactant in large extent, whereas the other reactant in a smaller value. If you have two reactant, concentration of one reactant is kept in large extent with respect to the other one. So, then the order with respect to the reactant which has lower concentration can be calculated. So, let us see more details about these two methods considering some examples. So, the first method, already we came to know the method is applicable when you have several reactants. When we have several reactants, sometimes the rate of the reaction may depend on all these reactants, or sometimes rate of the reaction may depend on only one or two reactants. In such case, to find out the exact relationship between rate of the reaction and concentration of these reactants, we use this method. So, when you have several reactants, what we have to do is, according to the first method, just keep one reactant at a constant value and vary the concentration of the other reactant. If you have two reactants, keep one reactant at a constant value of its concentration and vary the concentration of the other one. So, then the one which has variable concentration can be actually affect the rate of this case. In such case, order with respect to that, or the real influence of the reaction rate by this variable reactant can be calculated. So, think about this example. Here you are provided with some imaginary reaction, a very simple reaction where you have two reactants. What are the reactants? A and B are our reactants and C is the product. So, we are going to determine the real relationship between reaction rate and the concentration of A and B. So, you are provided with certain kinetic experimental data. So, let us see how do we use these experimental data to find out order with respect to A and order with respect to B. So, in this table you are provided with kinetic data of the experiment. They had done 3 experiments. We will discuss more details about this one later on, and before that let us find out what are the questions that they ask. So, here we are asked to determine order with respect to A, that is our first reactant. The second part, order with respect to B, that is our second reactant. Third part, total order of the reaction, and at last we are asked to find out rate constant of the reaction. So, before finding out these, so let us again go to the experimental results. Now, why do we say that they had done the reaction 3 times? Easily you can understand by observing the first column, they had done the experiment 3 times. And what about the second column? Second column gives the concentration of A. Why do we use a not sign here? Clearly go through the table. This kind of table only in most of the cases you will be provided with the A level exam. So, here they had given the A in square bracket and not is written as a subscript. That means they had given initial concentration of A and the unit is given, and third column is the initial concentration of the B. Third column is the initial concentration of the B, and in the last column you are provided with initial reaction rate. Initial reaction rate, always the rate of a chemical reaction is given in mole per decimeter cube per second. So, in these data, if you analyze these data carefully, in the first two data you can see the concentration of A is constant in the first experiment, and in the second experiment the concentration of A is constant, whereas the concentration of B is variable. According to the first and second data, the concentration of B is the variable. Now, consider first and third data. Consider first and third data. According to the first and third data, then concentration of A is the variable. Concentration of A is the variable, whereas concentration of B is constant, and we can't get such kind of relationship between first and second. So, let us see what are the data that you are supposed to use if you want to find out order with respect to A. Whenever you want to find out order with respect to A, actually you need to focus on the data, experimental data, where the concentration of A is variable. If you want to find out order with respect to A, focus on the table and identify the two experimental data where the concentration of A is the variable. So, can you all identify the correct data that we have to use? We have to use the first and third data. In the first and third data only, the concentration of A is variable, whereas concentration of B is a constant. So, to determine order with respect to A, we use first and third. How about to find out order with respect to B? If you want to find out order with respect to B, then B must be the variable, A must be constant. So, again go through the table carefully and identify what data you are supposed to use. B should be the variable, therefore, we use first and second. According to first and second data, you can see B concentration get varied, whereas concentration of A is a constant. So, we use first and second data to find out order with respect to B. Now, here you are provided with three experimental data now. So, let us see what are the experimental data that you are supposed to use to find out answers for these questions. The first one, we are going to find out order with respect to A. So, to find out order with respect to A, first of all we need to write the rate law expression. How do we write the rate law expression? In a previous lesson we discussed how to write that. Then R equals K, the first reactant A, order with respect to that X. You can consider any letter, here I had considered it as X, and the second reactant is B, order with respect to that is Y. So, our A and B are reactants, R is the reaction rate, K is the rate constant, X is the order with respect to that reactant, and Y is the order with respect to B. So, now we have to think what are the data that we are going to find out order with respect to A. Already we came to know to determine order with respect to A should be the variable, B has to be constant. A should be the variable and B has to be constant now. So, then we are going to use first and third data. Now, here you are provided with three experimental data now. Let us see what are the experimental data that you are supposed to use to find out order with respect to A. To find out order with respect to A should be the variable, B should be constant now. So, then we are going to use first and third data. To determine order with respect to A, we are going to use first and third data. So, let us substitute the given values. So, in the first one, the rate is given as 3.2 into 10 to the power minus 1. Then we need to write unit. The importance of writing unit is you get extra marks for the unit. If you do not write the unit, then you are not getting that marks. Then rate constant K, that we can write as it is because we do not know that one. And then concentration of A is our variable concentration. Here the concentration is given as 3. It is given in mole per decimeter cube. and the concentration of B is variable, B is constant here. So, I will write it as just B because it get cancelled off. Of course, if you want you can substitute the exact value. And then we are moving to the third experimental data. In the third experimental data, the rate is again given as 1.6 into 10 to the power minus 1, the unit mole per decimeter cube per second equals K, and the concentration of A is given as 1.5. Even in that one the concentration of B is same as previous one. So, I will write it as B because it get cancelled off. So, now what we are supposed to do is, this is our first experimental data, this is our third experimental data. So, we can easily divide the third one by first one. Now, let us see what we get when you divide third one by first. So, we get 2 from this side, from the left side. There has to be a correction, actually this one should be 3, this one should be 1.5. So, then here again you get again 2 in this side, order with respect to that is x. So, then how do we simplify this one? Now, hereafter you have to apply your basic mathematical knowledge. So, then to get this relationship x should be 1. So, then order with respect to A is 1. So, that is our first part. So, even in the exam what you have to do is substitute the given data with correct units, you get extra marks for the units, and then think how do you simplify these two to find out order with respect to that particular reactor. So, now we have calculated order with respect to A, and let us see how do you find out order with respect to B. To find out order with respect to B, again we are moving to the same method. We need to write rate expression. In the exam no need to write the rate expression again because already we had written, marks are given. Once you are provided marks in the first part, no need to write it again, but anyway to make it easy I will write the rate expression here even. So, then R equals K, already we had written this. Now, to find out order with respect to B, B should be the variable whereas A should be constant. Then we have to use first and second data. Now, we have to use first and second data. So, again I will consider the first data first. So, then rate is given as 3.2 into 10 to the power minus 1. The unit is given as mole per decimeter cube per second, and our rate constant. As you are going to determine order with respect to B, A is a constant. If you want you can substitute the exact given concentration of A. Here I will write it as just A because it get cancelled off. So, then B, the concentration of B is given as 1.5, the unit mole per decimeter cube. So, then Y, that is our first data. Then we have to consider the second data. Even in the second data rate is same as this one. The concentration of A will be same as earlier. I will just write it as A because it get cancelled off. Now, concentration of B is given as 2.5. This is our second data. Now, to find out order with respect to B, again I am going to divide the second one by first. So, from left side we get 1 and from right side we get 5 over 3, and here the power is 5. Now, to get this relationship again according to your maths knowledge easily you can understand y should be 0. Y should be 0. Then we have calculated order with respect to B, which is 0. That is our second part in the question. We have calculated order with respect to A as well as order with respect to B. Now, let us see the third part in the question. Third part, you are asked to find out total order of the reaction. How do you find out total order of the reaction? Total order is the summation of all the orders with respect to each and every reactant. When you have several reactants, total order is the summation of order with respect to each and every reactant. Here we have two reactants A and B. We came to know we had considered order with respect to A as x and order with respect to B as y. So, here total order means summation of x and y, and we came to know order with respect to A is 1 and order with respect to B is 0. So, then total order is 1. Very easy to find out total order. Once you calculated order with respect to each reactant, just get the summation. Now, fourth part, we are asked to calculate rate constant. To calculate rate constant, you can consider any three given information. I will consider the first one because it is the easiest one. So, then our rate expression was R equal K, concentration of A, order with respect to A is 1. Of course, when it is 1, no need to write it as the superscript, you can just write concentration of A, because this is our first example I had written here, and order with respect to B became 0, that we had calculated as 0. So, then we can rearrange this rate expression R equals K A. So, clearly you can understand in this reaction there are two reactants. What are the two reactants? A and B. Even though two reactants are there, the reaction rate depends only on the concentration of A. You can see in the rate law expression, the concentration of B does not appear in the expression. Then the reaction rate is independent of concentration of B. So, then all we need to substitute the given reaction rate in the first experiment and given concentration of A in the first experiment. So, according to the first experiment, reaction rate is given as 3.2 into 10 to the power minus 1 mole per decimeter cube per second equals, we are going to find out our rate constant K, and at that time concentration of A is given as 1.5 mole per decimeter cube. The concentration of A is given as 1.5 mole per decimeter cube. So, then all you need to simplify this equation to find out the value of K. So, this is how we calculate rate constant. Now, what will be the unit? One of the most important thing in the rate constant is to find out correct unit, because unlike reaction rate, the unit of rate constant will vary from one reaction to another reaction. Depending on the order with respect to each reactant, the unit of rate constant will vary. So, here the unit will be, this is our reaction rate unit, mole per decimeter cube per second. That is a constant, it does not matter whatever the reaction, all the time rate is given in mole per decimeter cube per second. And here we have concentration of A, now the unit mole per decimeter cube. So, then you can understand the unit of rate constant is per second. We came to know total order of the reaction is 1. The characteristic feature of first order reaction is the rate constant is having unit per second. So, clearly we can understand then this is a first order reaction. So, let us see then second method. Now, according to the second method, again second method is applicable when you have several reactants. In this method, what we are going to do is we keep concentration of one reactant in large extent, whereas the concentration of others should be a very small value. Actually, the one which has higher concentration should be 1000 times greater than the concentration of the other one. Then only the method is more suitable to apply. When you have two reactants, keep concentration of one reactant at a very low value, whereas the concentration of the other one at 1000 times greater than the one which has a smaller value. In such case, let us see how do we do the calculation. Now, the importance of this one, when you have concentration of one reactant 1000 times greater than the other one, we believe the concentration of that one will won't change throughout the experiment. We believe that concentration of that one won't change throughout the experiment. Actually, it is consumed because that one also a reactant. Reactants are consumed. No matter whether they have higher concentration or lower concentration, reactants are consumed. So, then the concentration of that one will slightly vary, but with respect to the initial large concentration, the variable amount is negligible. That is why we believe that concentration of that one remain constant. So, let us see the example. Here again you are provided with certain reaction. We have two reactants. We are considering examples which consist several two. Here I had considered examples with two reactants. Actually, both methods can be applied when you have two or more reactants. So, in this case they had given the rate as 4 into 10 to the power minus 5 and the concentration of P is given as 2 into 10 to the power minus 4 and the concentration of P is given as 2. So, what is the difference between concentrations of these two? You can clearly understand the concentration of P is much larger when compared to the concentration of Q. Actually, this one should be, I will make a correction here. One of them should be Q, should be Q. So, then concentration of Q is much larger than the concentration of P. So, then what we can do is we can find out order with respect to P. Make sure all the time in the second method we are going to determine order with respect to the one which has lower concentration, because the one which has higher concentration remain almost constant throughout the experiment. And here we are asked to calculate something, a new term, we call it as, it is given as pseudo rate constant. It is given as pseudo rate constant, that means it is not the real rate constant. Let us see how do we calculate that one. Now, even in this reaction we had two reactants known as P and Q, and we are asked to find out a new term called pseudo rate constant. So, let us see how do we find out this pseudo rate constant. To find out this pseudo rate constant, actually they have to mention the order with respect to each reactant. They have to mention order with respect to each reactant. So, let us see how do we calculate that one. So, let us write the rate expression for this reaction. Reaction rate equals rate constant into concentration of the first one P to a certain power, the concentration of the second reactant to a certain power. And in these two we came to know the one which has a very high concentration is Q. So, then I am going to rearrange this one. The concentration of Q is much larger than the concentration of P. Therefore, we can assume throughout this experiment the concentration of Q remain constant. So, I am going to rearrange this rate expression like this, R equals K dash into P to X. Now, what is this K dash? K dash is only the pseudo rate constant. So, this is only K dash. Then how do we define K dash? K dash is equal the rate constant into now I told to find out this pseudo rate constant they have to give the order with respect to P and Q. Actually it is not necessary to know order with respect to Q, but we should know order with respect to P. Now let us say if x is equal 1, if x is equal 1, what will happen to the rate expression? I can rearrange this one like this, R equal K dash then P. We are provided with reaction rate, it was given as 4 into 10 to the power minus 5. What is the unit? Mole per decimeter cube per second equal the pseudo rate constant K dash, and concentration of P is given as 2 into 10 to the power minus 4. 2 into 10 to the power minus 4. 2 into 10 to the power minus 4. Actually, you have to write the unit in that one even. So, then K dash can be calculated. K dash can be calculated. And what will be the unit? Per second. The unit is per second. So, to find out this pseudo rate constant, we should know the order with respect to Q. They have to give order with respect to Q. And to find out exact rate constant, how do we find out exact rate constant? To find out exact rate constant, we can use this relationship. K is the exact rate constant. To find out, we should know the concentration of Q. Of course, the concentration of Q is given, but order with respect to Q is not given. That is why we did not calculate the rate constant, but we calculated pseudo rate constant. So, there are some questions like this you get even in our A level paper, where you are asked to find out pseudo rate constant. Sometimes they have not given this term, this pseudo rate constant. Instead, you are asked to find out just K dash. It is given as K dash. So, then let us see some other calculations based on this rate law expression. Now, think about this reaction. Here they had mentioned it is a first order reaction. They had mentioned first order reaction. The reaction is given, the balanced chemical equation is given, and here you are provided with concentration of N2O5 as 2 into 10 to the power minus 2, and reaction rate is given as 1 into 10 to the power minus 2, and asked to calculate rate constant. We are asked to calculate rate constant. So, this kind of simple questions you get in our MCQ paper. So, let us see how do we simplify this one. So, we can write the rate expression like this. Why do we get the rate expression like this? We came to know order with respect to that one is given as, order with respect to that one is given as 1. Here the order is given as 1. So, that is why it is actually A is N2O5, the concentration of A mean that is the N2O5 concentration. So, then the values are substituted directly with units, correct unit. Make sure to substitute the given values with unit, and you will end up with the answer as 0.5 per second. The characteristic feature of first order reaction is always the unit will be per second. Clearly you can understand from this one, as unit is per second, this one should be first order. Now, here they had mentioned the given reaction is first order, then we should get exactly per second as the unit for the rate constant. A very simple question, but you get this kind of questions in our MCQ paper. Now, this is little complex reaction. Here you are provided with another chemical reaction, that is the reaction between O2 and nitrogen monoxide, and rate expression is given. They had given the rate law expression. According to this one, you can understand order with respect to O2 is given as 1, order with respect to NO is given as 2. Order with respect to O2 is given as 1, order with respect to NO is given as 2. Now, maybe you get confusion whether the order is same as the stoichiometry. There is a relationship between order and the stoichiometry, which will be discussed in another lesson. But here they had mentioned according to the rate expression, order with respect to O2 is 1 and order with respect to NO is 2. Do not worry about or do not get confused with the stoichiometric ratio. And here you are provided with concentrations of O2 and NO, and rate of the reaction is again given. You are asked to calculate rate constant. Again very simple, all the three informations are given, this one is given, this one is given, this one is given, and you are asked to find out the rate constant. The only difference is previous one had only one reactant, here you are having two reactants. What will be the total order of this reaction? Can you all find out what is the total order of this reaction? That is 3. Total order of this reaction is 3. Why do we say that total order of this reaction is 3? The summation of order with respect to O2, which is 1, and summation of order with respect to NO, which is 2. Then summation of 1 plus 1 and 2 mean that is 3. So, let us see what will be the rate constant. So, here the rate constant, to calculate rate constant, then we need to divide the reaction rate by concentration of oxygen and concentration of NO. Again clearly you can see in this question the given values are substituted with units. Even in the exam you have to substitute the given experimental data with correct units. You get extra marks for the units, then simplify. The special feature is the unit of the reaction, Now, here we have altogether 3 terms of concentration. Once you simplify, the unit is per mole, decimeter cube, power 6 and per second. You will end up with a different unit. Already I told, depending on the reaction, the rate constant unit will vary. It is not a constant like reaction rate. All the time reaction rate means the unit will be mole per decimeter cube per second, but when it comes to the rate constant, the unit will vary from one reaction to another reaction depending on the unit. In the previous example, it was per second because it is first order one. Now, the unit is this one because it is third order one. The total order is 3. We call this as a third order reaction. Now, let us see another example. Now, here you are provided with little complex reaction than the previous two. Why do we say that this one is complex than previous two? Here we get 2 products, 2 reactants are there and also we have 2 products. So, the 2 reactants are A and B. So, let us see whether the reaction rate depend on the concentration of both. Now, in the question here they had mentioned rate of the reaction is given as 5 into 10 to power minus 4. Rate of the reaction is given as 5 into 10 to power minus 4, and at that time the concentration of A and B are given. Again, what is the special feature of this one? The special feature of this one is the given experimental data is the concentration of B is very much larger than the concentration of A. When compared with the concentration of A, the value of concentration of B is much larger. And they haven't mentioned the exact order with respect to A and B, it is not given. But they had mentioned a sentence, go through this sentence. It has also been observed that the rate doubles as the concentration of A is double. What we can conclude from that one? That means when we double the concentration of A, reaction rate also double. That also get increased by 2 times. When we increase the concentration of A by 2 times, the reaction rate also get increased by 2 times. From that we can calculate order with respect to A should be how much? Order with respect to A should be 1, then only it get double. Now, think about a situation. I will write the rate expression to make it more clear for you. R equal K A to certain power, no? If x is equal 1, then we get R equal K A. So, when I increase the concentration of A by 2 times, the reaction rate get increased by 2 times. When I increase the concentration of A by 3 times, the rate also get increased by 3 times. That means the order with respect to A is 1. It is not 2, actually it should be 1. When we double the concentration of A, the reaction rate also double. Then order with respect to A is double, A is 1 and rate get double. And we are asked to calculate rate constant. So, let us see how do we calculate rate constant of this reaction. So, actually we are not calculating the exact rate constant. Here again we are calculating pseudo rate constant. So, K dash is that is because K dash equals rate constant into concentration of the other reactant B to a certain power. The concentration of B is of course given, but the problem is order with respect to B is not given. So, then pseudo rate constant of this reaction is given like this, and again we can find out unit of this one is unit of the pseudo rate constant is per second, because order with respect to A is 1. Now, let us see the method of initial rate. In most of the experimental data, we are using initial rate to determine rate law. If you consider a certain balance equation, just by looking at the balance equation, we can't predict the exact reaction rate law, because the rate constant as well as order with respect to each reactant has to be calculated by experimental data. Definitely we need certain experimental data to find out order with respect to each reactant and to find out rate constant. As long as if we know the rate constant and the order with respect to each reactant, then only we can give the rate law expression. Just by looking at this balanced chemical equation, we can't predict this one. So, this initial method is really important to get this exact order with respect to each and every reactant. Of course, you can use, as we discussed earlier, the average reaction rate, or you can use instantaneous reaction rate to get idea about the reaction rate. But whenever you want to predict reaction rate law, to predict the rate law, we have to go for the initial reaction rate. What is this initial reaction rate? That already we had discussed in a previous lesson. Initial reaction rate means that is the rate of the reaction at the moment you mix the two reactants. At that time, the reaction rate is known as initial rate. So, if you are going to determine initial rate, you need to consider the initial concentration of reactant. Make sure whenever you are going to use initial rate, along with that substitute the initial concentration of reactant. Then only you can get the correct relationship for the rate law. And if you are going to find out order with respect to certain reactant, and when you apply this initial method, initial rate law method, the easiest way is we can change concentration of one reactant while keeping the concentration of other reactant at constant value. While we vary the concentration of one reactant, we can keep the concentration of all the other reactant at constant value, and also total volume and temperature has to be constant. What is the importance of having constant value for the temperature? In a previous lesson, we discussed the factors that affect reaction rate. We came to know there are so many factors that affect reaction rate. One of the important factors that affect reaction rate is temperature. In most of the chemical reactions, you can say in almost all the reactions, the rate can be increased by increase in temperature. But here we need to know how the rate will vary when the concentration of reactants will vary. We do not want to see how the reaction rate depends on the temperature. The dependency of temperature can be discussed in a different way, but in our rate law expression, all we need to know how the reaction rate varies with the concentration of reactant. Therefore, definitely temperature has to be constant. Why do we need to have total volume at a constant value? Now, here we came to know concentration of one reactant at a constant value while varying the other one. So, if you just vary the other one while keeping the concentration of the suitable reactant at a constant value, if you do not maintain total volume at a constant value, if you do not maintain total volume at a constant value in the experimental setup, definitely even in the one which we had constant concentration will vary. When the total volume of the system varies, the concentration of the one which you are going to try to keep in a constant value also varies. That is why we need to have a total volume as well as temperature at constant value in this method. Rate of the reaction can be measured with respect to the one which has the variable reactant concentration. The rate of the reaction can be measured with respect to the one which has variable concentration. So, those two data can be substituted to find out order with respect to that particular reactant. So, if you are going for a graphical method, in a previous lesson we came to know how to draw certain graphs depending on the rate of the reaction and concentration of reactant. So, if you are going to apply graphical method to find out order with respect to certain reactant, in such case we need to have at least 5 data to draw the graph. At least 5 data has to be there to draw the graph. Now, let us see what kind of graphs can be used to find out order. Simply the order can be calculated by, as we discussed in the previous way, we can go for a calculation method, but also we can get the order by graphical method. So, this is one type of graph that we can use to find out order with respect to certain reactant. Whenever it is the variation of concentration is given with the time. Actually, here the concentration of reactants are considered. Of course, instead of the rate, you can consider to find out the reaction rate, you can consider concentration of a reactant as well as you can consider concentration of a product. But in this graph, as it get decreased with the time, you can see the concentrations get decreased. Definitely this concentration means the concentration of reactant. For zero order reaction, you get a straight line which has a negative slope, and for first and second order and first order reaction, the graph will be same, it's same pattern. Even for the third order reaction, it's same pattern. You get a curve, downward curve. Now, in zero order reaction, we get a straight line because consumed amount of the reactant is a constant throughout the time. Certain amount of reactant is consumed during the reaction, and that amount is again a constant. That is why you get a straight line. Easily from the shape of the graph, we can identify zero order one, because zero order one is having a different shape. The problem is in the first and second order. In the first and second order, you will end up with same type of graph. So, then this method is not very good to use to determine order with respect to certain reactant when it is first or second, because you will end up with the same shape. So, let us see the other graph that we can draw. Now, this is the second graph that we can use to find out order with respect to certain reactant. Now, here we plot the variation of the reaction rate with concentration. We plot the variation of reaction rate with concentration. In zero order reaction, zero order means the reaction rate does not depend on the concentration of the reactor. In such case, we get a straight line which is parallel to x axis. We get a straight line which is parallel to x axis. The reason is, no matter whatever the concentration of the reactant, the rate remains constant. The rate remains constant, that is because it is independent of the concentration of that reactant. So, in zero order reaction, easily you can identify from the shape. In first order reaction, we get a straight line which pass through origin. In first order reaction, we get a straight line which pass through origin, as in this green color line. The reason is, in first order reaction, when I increase the concentration of reactant by 2 times, the rate get increased by 2 times. When I increase the concentration of the reactant by 3 times, the rate get increased by 3 times. When I increase the concentration of the reactant by 4 times, the rate also get increased by 4 times. It has a linear relationship. Because of that, we can use easily this straight line which pass through origin, emphasize it is a first order reaction. So, the next one, the red color one, it is a second order one where you get upward curve, exponential curve. We get upward exponential curve not only for second order reaction, it is for third as well as fourth order reaction, you get same pattern. Again, the method is not suitable to find out order with respect to a certain reactant when it is second or higher order reaction. You will end up with same kind of graph, but easily first order and zero order can be obtained by this graph. So, then the last graph. Before going to the last graph, let us see how do we get this graph by writing normal rate law expression, considering this simple example. Let us write the rate expression for this one. To make it easy, I had considered a situation where you have only one reactant, then we can write the rate law expression R equal K, our reactant is A, order with respect to that I had considered as X. The stoichiometric coefficient of this one is simple A, but I had considered order as X. Sometimes they have a relationship, that means the order and the stoichiometric coefficient have a relationship. Sometimes they do not have a relationship. More details will be discussed in a later lesson. And we are going to rearrange this equation. Now, multiply whole equation by log. Multiply whole equation by log. So, then we get log R equal log K. Multiplication means addition of log. So, then I am going to use addition, then x can be written like this, then log A. So, this is our new equation. The advantage of this one is it does not matter. Now, if you can remember, the first graph I told easily can be used to identify when order is 0. The second graph I told easily you can use to identify when order is 0 or 1. But we came to know if you have higher order, second or higher order, the order cannot be identified because you will end up with same shape in the graph. But to find out exact order with respect to any reactant, whatever the order, it does not matter, we can use this expression. So, all we need to do is consider this value in y axis and this value in x axis. You get a x axis, you get a new graph. What is this one then? This is our intercept, this has a positive intercept and this is our slope. We get y equal mx plus c type graph where the slope as well as intercept are positive. So, that is only our third graph. The advantage of this one is order with respect to certain reactant directly can be identified as the slope. The slope of the graph is equal to the order with respect to that particular reactant. It does not matter whether it is whatever order. When the reaction is 0 order 1, then slope will be 0. When it is first order reaction, then x is equal 1 and slope will be 1. When it is second order reaction, x is equal 2 and slope even 2. So, let us see what kind of shape we get for the graph. So, this is the graph. So, here you can see the variation of log value of rate. Log value of the rate is given along with the variation of log value of the concentration. If it is 0 order, we came to know the slope is 0. If it is 0 order, slope is 0. And if it is first order, the slope will be 1. If it is second order, slope is equal to 2. Because of that, easily you can calculate the order with respect to any reactant. This is the advantage of the third graph. So, in the exam, what kind of method we are going to select? In the exam, what kind of method we are going to select to find out the order with respect to certain reactant? We came to know to plot the graph, at least 5 data has to be given. So, let us say here you are provided with a certain question in our A level paper, you are provided with several experimental data. But normally we say it's not suitable to go for the graphical method. The reason is it is time consuming. The graphical method is time consuming. Instead of the graphical method, you can select specific data where the concentration of particular reactant is a constant and the other particular reactant is a variable. So, simply using simultaneous equation method, you can get the order with respect to certain reactant. As long as they haven't mentioned what kind of method has to be used, make sure to go for that simultaneous equation method. That means just by substituting given experimental data in our rate law expression, because this graphical method, even though you can get the correct answer, it takes lot of time to draw the graph, it will take lot of time. So, do not go for this method to find out order with respect to certain reactor. So, then that is all we are supposed to discuss today. Here we discuss about a certain competency, how to determine reaction rate. That is our fourth competency in this unit, how to determine the reaction rate. That means order with respect to reactant and rate constant, both has to be known to find out the rate. To apply rate law and to find out reaction rate, we should know the exact order of the particular reactant and rate constant. So, to calculate those two, we came to know there are two methods. We discussed more details about those two methods and also we discussed some examples regarding those two methods. So, in the exam, carefully go through the given informations and see what method that you are supposed to apply. Maybe you are supposed to apply the first method where the concentration of one is a variable. Maybe you are supposed to apply the second method, concentration of one reactant is a large extent when compared to the other one. And we will discuss more details about this chemical kinetics. There are some other theory part that has to be discussed in this unit in future lessons. And you can watch all these lessons in YouTube channel NIE, and also you can get more informations from the resource book published in NIE. You can freely download all these resource books, go through those, you can get more informations and more examples regarding these calculations. It's better to have lot of examples to do before going to the exam. So, that is all about today's lesson. So, let us see another theory part in a different lesson which is very important in our syllabus. Thank you.